something to treat that wax to reduce those virus levels. Because ultimately we want to get to the level where we can help our bees stay healthier. So some of the bee treatments I used, I need my sick bees, my high virus bees, and my healthier bees, which are obviously the lower virus bees. So I do this by correlating the mite levels. So for my sick bees, we got lots of mites, and that's perfect because we have a mite rearing yard at the University of Manitoba. And for the low mite bees, for low viruses, we take them from New Zealand packages each spring. So each year we have new bees from New Zealand that we use as our low virus treatment. And for wax, I basically use those same bees to get my dirty wax or high virus wax, which is just wax foundation that I've exposed to those sicker bees, and also my low virus wax, which is just the foundation exposed to those lower virus bees. So just a little technical note, this is how I've done my molecular work, which is basically some standard kits, as well as a method I developed to detect viruses from wax. So first question, do these wax-borne viruses actually affect brood? So to do this, I did a little experiment in our overwintering building where I used some observation hives. And here's just the outside of the building. They're connected with tunnels to the outside, so I can have them in the overwintering building and manipulate them in there, but they can still forage normally outside. So for this, I had 10 different observation hives. So I had 2 treatments. One with low virus wax frames and one with high virus wax frames. And with those I had New Zealand bees. So I had my clean bees on 2 treatments to compare the effect of that high virus wax and low virus wax. Unfortunately, because of maybe a bad wasp year or just that we had bees outside the overwintering building and other hives, I had a robbing event and I lost some of my colonies that were in the observation hives over the weekend. So my sample size went down from a nice balanced 5 and 5 each to 4 and 3. So that's one reason that I'm doing another field season. So I had the queens lay on those 2 different wax types, and then I sampled the pupae at the pink or purple-eyed stage to test for viruses. So this is looking at BQCV as the light blue and DWV is the dark blue. Low virus wax pupae are on the left, high virus wax are on the right. I'm just going to break this down. So first looking at the difference between BQCV and DWV. For both treatments, there's a significant difference between the 2 viruses, with DWV being in higher amounts, and that's to be expected. So looking at the difference in BQCV in the 2 treatment groups, it actually is lower on the dirtier wax. So that was a really interesting result. It's possible that there might be some sort of interaction with the immune system of the bees. There might be some sort of immune buffering effect or bolstering effect going on there, or something else I'll get into in a moment. And DWV, it was the opposite. On the dirtier wax, it went up. So that was what I was expecting, and it's interesting that these 2 viruses are behaving differently. So 2 viruses are having a different relationship with the wax. It's possible that with the BQCV going down, is that maybe an immune effect. With DWV, it's possible that there's actually infection coming from the wax. But it could also be possible that there's competition within the bees themselves based on what they're exposed to on the wax. So the bees with higher DWV from the high virus wax might be outcompeting the BQCV within those bees. So the levels might be changed from that. But I had that sample size reduction because of the robbing event. So I have low statistical power for these data, but they're still really interesting. And the next question was, can I actually reduce these wax-borne viruses with some kind of treatment? I did a storage experiment where I stored high virus wax at 3 different temperatures that would be easily accessible for beekeepers. Freezer temperature of -20, a cold room at 5 degrees, and just 20 degrees room temperature. and I sampled it at 4 time periods at 1 day, 2 days, 15 days, and 30 days. So for the experiment, I had 10 different frames of wax that I had exposed to those high virus bees, and I cut them up into little pieces so I could sample from the same petri dish at each of those times. So I just went into the same petri dish and took a new piece out every time. For the data I have today, I have only tested half of the samples, so I only have 5 reps, but it's a good balanced spread. So looking at black queen cell virus with storage time, the first 3, I sampled at 1 day, 7 days, 15 days, 30 days, not 1 day, 2 day. So there was a decrease significantly in the viruses at 30 days storage time. And the same with DWV, it decreased significantly by 30 days. And there was actually no effect of the storage temperature on the virus levels. So I think that storage time has, regardless of the temperature, has a good effect on the virus levels. But with the other samples I have yet to test, which I'll be doing in the next bit, something else might come out with the temperature, because I would have expected to see virus levels staying higher at lower temperatures and possibly degrading faster at the higher temperatures. So it's possible that it still might be there, and I'll tell you next year. So far, I have evidence that these waxborne viruses are affecting the virus infections in bees, and that we can decrease the viruses on wax with time. But I need some more information here. I need to see stronger evidence that these waxborne viruses are affecting the infection in bees, and then also, not only do I want to see a reduction in the viruses on wax, I want to see if that reduction also affects the infections in the bees. So does it even matter if we can reduce over 30 days those viruses? So this summer, oh yes, because the ultimate thing is I want to make recommendations. I can't do that yet. I'm sure it won't hurt you to store your wax at any time, but I can't make full recommendations with the data I do have right now. So this summer I'm very excited about this experiment. I initially asked Rob for 30 colonies and he said, let's do 60. So that was a very exciting moment for me. So this is going to be a wax rearing experiment like I did in the observations hives, but blown up to the nuke scale, and I'm going to have 60 different nukes and different treatments. So now I'm going to be testing wax that was freshly removed, so freshly exposed to either the high virus or low virus bees. Same wax, but then stored for 30 days, and the same wax, but irradiated. So Steve has some connection with, I think, a gamma radiation center in BC, because the Pinawa one closed recently, so we can't use that. So hopefully we'll be able to ship wax out to BC and get it back. And then I'll be putting low virus bees in all these colonies, and then testing. So now I'm going from the 10 observation hives to now 60 nucleus colonies, so my sample size is much better. And I'm going to be testing the bees and the wax at different time points along the experiment. So I'm going to be testing both when I'm removing the frame from the colony to see the base levels, whether they're fresh or stored or before they're radiated, as well as the levels in the workers that have put their viruses on that wax. The second stage will be when they're pupae, probably pink or purple-eyed pupae, test those for viruses just like I did with that first experiment, as also testing the wax that they're on to see if the levels may have changed because they're now exposed to only low virus bees. And I'm also going to be marking pupae that I don't test for viruses with paint, and I'm going to come back probably after 2 weeks and sample those as adults to see if the virus levels have anything interesting going on at that time. I'm also going to be doing lifespan monitoring, so longevity of those bees after they emerge. So probably once every week for a few weeks, maybe a couple months, to see if there's maybe a difference in the longevity of those bees based on the treatments. And I'm going to be testing the bees for BQCV, DWV, IAPV, and probably SBV, saccharid virus. And I might also be testing for the different strains of DWV, because we're getting more data now that there are different strains of DWV, and some of them are more virulent or dangerous to bees than others, so it'd be interesting to see if there might be a difference in the virulence of those strains between high virus wax and low virus wax. So ultimately, again, I want to bring this back to you and say, do these viruses actually affect the bees, and what can we do about it? So it'd be interesting to see, of course, the virus levels in brood, then as adults over time. It might vary by virus, like that BQCV-DWV relationship where they're opposite. And of course, bee lifespan. And then can we control those effectively with something as simple as a storage treatment, or does radiation work better, or just the same? So I've left lots of time for Rob to talk, so I'd like to thank you all for being here still for my talk. And I'll take any questions. Sorry.
You just had some, I just want to ask a question. You had hives inside. What is the reason for them being in the building?
Well, personally, I think it's because Steve Purnell built them for his own project and he sort of wanted someone else to use them. But it's also good to keep a closer eye on them to make sure that the queen is laying without having to disturb them a lot. So it is good on a small scale, but for my bigger scale experiment, I definitely want to go to larger, stronger colonies to avoid losing colonies like I did in the observation hives. Anyone? Oh, yeah.
So then when you stored them, what parameters do you have to store them? Is it like airtight? Is it, like how did you store them to keep them away?
For wax storage, I store the wax in Petri dishes, and those were in airtight Ziploc bags. Anything else? Thank you.